Hello, we are back with module number 38 and we are going to talk about a little bit more about the quantifiers. Quantifiers have been introduced to you in the earlier module symbolically and know how to use them in translations and so on, but we haven't spoken about the scope of a quantifier. What is that and how to utilize that knowledge and so on, we will talk about it. But scope of a quantifier will help us to identify also an important thing, namely the free and the bound variables. Okay. So, we will use the idea of the scope of a quantifier to define free and bound variables, and then we also will utilize that scope of a quantifier to talk about the difference between quantified propositions and truth functional compounds in predicate logic. We have both kinds present in predicate logic. So, some of you might be confused why we are calling this proposition quantified, why we are calling this propositional truth functional compound. That confusion should be cleared. So, we will talk about that also. So, this is what we are going to discuss today in our module number 38. See, the job of a quantifier, as I have told you, is to interpret how many of the variable used. So, you are talking about the quantity of the variable used, but for that purpose the variable has to be, the variable that you are using has to be within the scope of the quantifier. The interpretation of the variable in terms of quantity can happen only if it lies within the scope of the quantifier. But what does scope mean here? What does it mean to say the quantifier scope is this? Well, scope here means the extent of the interpretive power of the quantifier. How far can it interpret the quantifier? So, this is the idea, and we will try to, this is our initial understanding of what a scope is, the limit or the extent of the power of the quantifier to interpret the variables. This is what we mean by scope of a quantifier. Now comes the operationalization. How far does the scope of a quantifier go? How will we know that this is where the scope of the quantifier is and this is where it is not? So, let us talk about that. Now, slowly we will build it up, that by convention, you know, I have told you that a quantifier comes with a variable, that is part of a quantifier symbol. Remember, by convention the individual variable that you are using as part of the quantifier symbol is already within the scope of the quantifier. That is the default. For example, if you are using for all x, this is how you use quantifier, right, and within the bracket. So, there is a variable present here, namely this x, and that x by default is within the scope of this quantifier. Get it? So, that automatically is within the scope of the quantifier. This is the convention. But then there is also, you are using other variables after that, right. Only this cannot be a full sentence. So, there are other variables. Remember that the variable that is immediately adjacent to the quantifier symbol also lies within the scope of the quantifier, if it is the same variable that is used in the quantifier symbol. So, for example, if you have this for all x f x, right. Now, here you have two occurrences of the x, which is a variable. Notice that already I said the first occurrence is by default within the scope of the quantifier, and now I am adding to that the variable occurring immediately adjacent to the quantifier symbol is also within the scope of the quantifier, which covers this second occurrence of the x. So, that is also within the scope. So, first this x is already within, and then because it is immediately adjacent to the quantifier symbol, this x's occurrence is also within the scope of the quantifier. Further, if a quantifier is followed by a parenthesis, and if that is the case, then the variables that are occurring between the opening and the closing parenthesis matching with the quantifier symbol will be all within the scope of the quantifier. Once more, after this, see, up to here is default. After that, if you have a parenthesis coming up and same variables are also used, then until the bracket is closed, all of that will be assumed as within the scope of the same quantifier. For example, take a look. Take a look. There are 3 occurrences here. The first 2, as you know, were already covered or already within the scope of this quantifier. In order to bring this third occurrence within the scope of the quantifier, what we have done is to use this parenthesis. Get it? So, because now this is the convention to read that this covers this x and as well as this x until the matching parenthesis is met. Get it? So, this is something to learn. Or for example, take a look at this existential quantifier. Whatever I have said about the universal quantifier applies to the existential quantifier as well. So, this x by default is part of the quantifier and is within the scope. This is being adjacent, and this is because there is this parenthesis all around it. And now you probably understand why we have been using this parenthesis all along with the quantifier expression, mainly to indicate that the scope of the quantifier is from here to here. So, here in this case the scope of the quantifier is from here all the way to here, from here all the way to here. Okay, this is what we have established. All right. So, this is to understand how the scope of a quantifier works in our system. Now, I am going to use this idea of scope of a quantifier to then further talk about free and bound variables. Okay. Consider, for example, these 2 sentences. Take a look, take a closer look, okay, so that you can see what is there in the first sentence and what is there in the second sentence. Now I am going to define what a bound variable is. The occurrence of a variable that is within the scope of a quantifier is called bound, and it goes the other way. If the occurrence of a variable is within the scope of a quantifier, then the occurrence of the variable is called bound, both. This is what is desirable, that every occurrence of a variable is bound in this kind of sense, that it is lying within the scope of some quantifier or other. Get it? This is what is desirable. On the other hand, there is something called free variables. A free variables is the occurrence of a variable that is not bound in this sense, that is the occurrence of a variable which does not lie in the scope of a quantifier. That is what a free variable is. And remember, in our first order predicate logic system, it is not a desirable kind of a situation. Free variables are not really desirable. Okay? Why? Because these are open statements, we cannot interpret them. So, variable occurrences need to be interpreted also, right, and the quantifier helps us with the quantity understanding. There are other things also. So, remember, free variables are not desirable ones. What we need is the bound variable situation in every properly formatted sentence of first order predicate logic. Now, let us go back to the original pair, that the one that we started this page with. If you look at this sentence, the first sentence, then we have 3 occurrence of the variable x, and as explained already in the previous page, every occurrence of this variable x is bound. Now you know what bound variables are. So, I will say every occurrence of this x is bound, because it lies within the scope of this quantifier. Okay. Now, compare that with the situation we have in the second sentence. Again, we have 3 occurrences of the x, the variable x. The first 2, please note, are bound, because one is part of the quantifier, the second one is adjacent, but look at this third occurrence of the x. Okay. There is no indication that this one lies within the scope of this quantifier. So, this third occurrence is free, and this is a sentence that we cannot allow syntactically as a properly formed or well formed sentence, and we do not know how to read this also. So, this is not a desirable situation. Did you understand that? So, free occurrences, free variables are to be avoided at all cost. Our goal will be to have sentences where the occurrence of the variable is bound by some quantifier or other. Okay? So, as said, free variables are not really welcome here. You may say the freedom of expression, freedom of speech, etc. are desirable, but free variables is certainly not desirable in this case, in the way I explained. Now, I will explain the difference between the truth functional compound and the quantified statements also in terms of the scope of the quantifier. So, here it comes. See, when we say quantified propositions, we mean those propositions where quantifier is the main logical operator. Now, how do we know quantifier is the main logical operator? When the quantifier has the scope over the entire statement. Once more, quantified statements are those statements where a quantifier has the entire sentence within its scope. That is what we call quantified statements. Okay? So, entire statement has to be within the scope of a quantifier. For example, take a look at this one. Every occurrence of this is bound by this quantifier, and this is what we mean by saying that the entire sentence is within the scope of this quantifier. This is a legitimate quantified statement. Whereas, the truth functional compounds are those where the main logical operator is a truth functional connective. So, the entire sentence is going to be within the scope of that connective, not under a quantifier. Okay? So, the proposition is going to look different, is to be interpreted also differently, and its function also will be different. Take a look, for example, here. What you find here is that we have quantified statements here, quantified statements here, right? But the whole sentence is a what? A truth functional compound. How do I know? Well, take a look. This is your wedge. The same V or wedge, that was a truth functional connective, and it follows the truth table of the wedge, the either or, except the disjuncts are all quantified statements. There is a vast difference between this kind of sentence and this kind of sentence. Here you do not apply the truth table, you can't, but here this is bound to follow the truth table of the wedge, right? And this is what we will call the truth functional compound. This is what we will call the quantified statement. So, what we have learned today in terms of scope is enormous, in the sense that we can now operationalize, we can use this to understand other concepts such as distinction between truth functional compound and quantified statement, as well as free and bound variables. There is one more thing that we need to know, and that is universe of discourse. See, the quantifier helps to understand how many, and the universe of discourse helps to understand what are we talking about, what kind of things are we talking about. So, for interpretation along with the quantifier, the universe of discourse is very, very important. Let me show you. Universe of discourse can be unrestricted as in open. If left open and unrestricted, it includes everything. Everything that possibly you can include in that, which is what we call the common context. When we start a conversation, our context is open. It is assumed to be common to the conversants, right? Between them, they know what is normal and what is common and so on. So, unrestricted UD is sort of like that. You include everything that you intend to be included. For example, let me show you how it works, where Ix is the predicate letter for x is important. Then in that unrestricted UD, where there is no bar, for all x, Ix means everything in that UD is important, right? Everything. This is what you are saying. Everything is important. Now, if we restrict it, we can artificially restrict the UD, saying that I am only talking about this. I am only talking about certain things, right? That you can do also. If you specify the UD, then you will see the interpretation of the sentence changes. So, let us try that with the same sentence for all x, Ix, but here we are going to restrict the UD to the papers on this table. Which table? This table, the one that we are using right now. And there are a lot of papers here. So, in this restricted UD, where we are talking about the papers on this table, the for all x, Ix would mean what? Every paper on this table is important. See how this interpretation changed? I did not change the sentence. We did not change the quantifier. What did we change? The context. The universe of discourse is nothing but the context. So, it depends on the contextual meaning also, as it should. So, restricting the UD changes the meaning, unrestricted UD changes the meaning, and so on and so forth. Now, the default is, the convention is that if nothing is mentioned when you are asked in the translation or anywhere, when there is no special mention of the UD, you are to understand we are talking about an unrestricted UD. If it is restricted artificially, that will be mentioned. Okay, we are talking about this specific UD, not all, not everything. Okay, so keep that in mind. So, let us sum it up then. What we have learned is that there are three kinds of statements that we allow in our first order predicate logic. The first one are the atomic statements, where we have the constants appearing with the predicate symbols and so on, and they look like this. So, you have the predicate letter followed by constants, the predicate letter followed by number of lined up ordered sequence of constants or variables. We have seen that. This is one kind of a situation. Then we also have the truth functional compounds, and we know how to define them, how to understand them also, and they may look like this. Please note that even in the truth functional compound, you can have the presence of a quantifier, right? That is not barred out, that is not eliminated, but the nature of the sentence remains truth functional compound. So, you might have things like this. You also might have this. See here, it is a conjunction between m and there exists at least one x such that x is dx. Okay. So, that is a truth functional compound for reasons that I have given already in terms of scope. And then there are full fledged quantified statements, for example, like this. So, all three are legitimate denizens of this world of first order predicate logic. We have somewhat mastered the syntax of first order predicate logic. So, we will end it here today, and we will come back with more in the next module. Thank you very much. Bye bye.